Hey guys, my name is John Miller, and my presentation focuses on the ecological productivity of upwelling areas. The term upwelling is used to describe the process of wind driven movement of cold, nutrient rich water from the bottom of the ocean up into the euphotic zone, replacing the warmer surface water, which is usually nutrient depleted. These nutrients include nitrate, phosphate, and silicic acid. Upwelling occurs as a result from the Earth's wind patterns and rotation, specifically the Coriolis effect. The Earth rotates on its axis from west to east, causing winds to move water at right angles to the direction the wind is blowing. Thus, in the northern hemisphere, the winds generally tend to veer right, and in the south, they veer left. The Coriolis effect is mainly responsible for upwelling in coastal regions, but it also causes upwelling in the open ocean near the equator. Trade winds can also influence upwelling at the equator by blowing surface water, both north and south. Wind patterns and cyclones can also yield upwelling directly beneath the eye of the storm. The cold water that emerges to the surface will actually help weaken the cyclone. Depending on regional wind conditions, coastal upwelling systems can either be year round or seasonal. The year round systems are known as the major upwelling regions. These major upwelling regions are located off the coasts of California, Peru, Chile, Northwest Africa, Southwest Africa, and Portugal. Seasonal upwelling systems exist off the coast of Somalia, Yemen, Oman, Sumatra, and in the South China Sea. There are also seasonal coastal upwelling systems along the southwest coast of India and the southern shelves of Australia. Other types of coastal upwelling systems exist in the Greenbelt of the Bering Sea, the Grand Banks, the Agulhas Bank, and the Shelf Break region of the Malvinas Current. Upwelling in these areas is caused by dynamic uplift, shelf breaking upwelling, and the Irish Sea and the Yellow Sea, where nutrient influx is induced by tidal mixing fronts. Upwelling brings nutrients, specifically nitrates, up into the photic zone. If light is not limiting, the influx of nitrates stimulates phytoplankton growth, which causes an increase in herbivore activity such as zooplankton and krill. This can increase herbivore biomass and numbers. This attracts and provides more food for planktivorous fish such as anchovies, herring, and sardines, and in turn, carnivores and top predators like dolphins, seals, and sharks. In short, because the deep water brought to the surface is often rich in nutrients, coastal upwelling supports the production and growth of seaweed and plankton. These in turn provide food for fish, marine mammals, marine birds, and people. Upwelling and its effects also increase productivity in something called the microbial loop. Increase in productivity results in an increase in dissolved organic matter as products of photosynthesis and metabolism. Some of this is reabsorbed by phytoplankton, but most is taken up by planktonic bacteria, which increases production and growth. Protozooplankton feed on the bacteria, which is then fed on by zooplankton, and this returns lost energy back to the classical food web. A 25,000 square kilometer region off the west coast of Peru undergoes permanent coastal upwelling due to equatorial winds. This upwelling system creates one of the richest and most productive fishing grounds in the world. Every 2 to 7 years, El Nino events trigger a strong decrease in productivity in this region in Peru. El Nino refers to warmer than average ocean surface temperature created by weakening trade winds over the equator in the Pacific. El Nino decreases productivity immensely because it severely depletes nutrient availability. The planktonic biomass decreases during El Nino, triggers habitat changes and high mortality for several fish populations. El Nino also occurs and severely impacts other areas in the Pacific, such as Chile and Argentina. One major impact of upwelling involves the displacement of microscopic larvae of marine fish and invertebrates. They may drift in the ocean currents for months while they develop. and upwelling may carry them out of their natural habitat, which can reduce their survivability. However, upwelling can carry larvae of marine fish and invertebrate out of their natural habitat. The process may instead carry the larvae to mainland coral reefs, where they may become established, which promotes the dispersion of the species. In some upwelling regions, including off the west coast of South Africa, these high biomass phytoplankton blooms occur as a result of the influx of nutrients, which can include toxic, harmful algal bloom species, and may contribute to local anoxia and subsequent macrofaunal mortality. This can result in significant negative effects to the local ecosystem, fisheries, and human health. Coastal upwelling regions only cover about 1% of the total area of the world's oceans, but they provide for about 50% of the fish harvest brought back to shore by the world's fisheries. Overall, upwelling is an invaluable ocean phenomenon because it infuses coastal waters with essential nutrients that fuel dramatic primary production that percolates high levels of energy up the food chain, generating some of the world's most fertile ecosystems.